Alright guys, so now we are going to talk about the section 3.2, quadratic function and graphs. You will understand why we have talked already, we have introduced in section 3.1 the complex number. So quadratic function, a quadratic function is any function with the form ax squared plus bx plus c where a is different than 0. What we're trying to focus on is trying to change this expression into another expression, f of x equal a times x minus h squared plus k, where the point defining by the coordinate h for x and k for y is defined as the vertex. Okay, the point defining by the coordinate h and k is defined by the vertex of the parabola, because a quadratic function is a parabola. All right, so if you look at the example number 1, when you have your expression defined as f of x equal negative 2 times x plus 3 squared minus 4, what you can do is compare that expression to the expression f of x equal a times x minus h squared plus k. And so to be able to define the value of h and k, well, first of all, you don't have a plus right here, so you can put a plus. That doesn't change anything, but at least it is helping you to define that k is going to be equal to negative 4. And if I want to look at the value of h, I need to have, right there, I'm supposed to have a negative, and I have a plus. So if I have to have a plus with a negative, I need to have another negative, which is going to be negative 3. So minus negative 3. And if I have minus negative 3, that means h is going to be equal to negative 3. Just, I could do also is name a equal negative 2. Now, I know that my vertex is defined by negative 3 and negative 4, and if I graph my parabola, I will see that when x equal negative 3 right here and y equal negative 4 right there, negative 3 and x is equal to 4, I have my vertex. I have the vertex of my parabola. Now, my parabola is going down because of the coefficient a, which is negative. Let's take a look at the example number 2. What do we have? The question is, find the vertex. Well, we know that the vertex is defined as h, and k is also the function, the value of your function when x equal h. Okay, and that would be the value of k. So, in this case, what do we have? Pretty simple. When I try to find the coordinate h, which is the coordinate x of your vertex, I'm going to have minus b. So first of all, to be able to avoid to make a mistake in what is the value of a, what is the value of b, and what is the value of c, what I want to do is look at the function f of x equal 4x squared plus 16x negative 3, and I can add a plus right here. Now I have a plus, and the plus by minus will be minus 3, so it doesn't change anything, but at least it helped me to avoid to make a mistake when I'm going to say is a equal 4, b equal 16, and c equal negative 3. Now I'm done with this. If I calculate h, which is negative b divided by 2a, I'm going to have minus 16 divided by 2 by 4, which is 8. I end up to have negative 16 divided by 8, which is negative 2. Now I know the value of h, so I can calculate f of h, which is f of negative 2. I substitute the value of negative 2 inside my expression, and so I end up to find 19. And so the vertex will be negative 2 and negative 19. And as you can see on the graph of our function, I have a vertex defined by the coordinate -2 and -19. All right, so let's take a look at this example number 1, section 3.2. Let's try to review a little bit what we have done already. If I want to represent this function, what I could do is first represent the function x squared. So if that is x squared, well, x plus 3 squared, I know it's going to be, so let's try to use another color for that. Let's try to use purple. Okay, x plus 3, it's going to be a shift. Is it going to be a vertical or horizontal? It's going to be horizontal, and because it's a plus, it's going to be to the left. So this right here would be x plus 3 square. All right, now I need to focus on the negative x plus 3. What do I have when I have negative x plus 3? Well, negative x plus 3, it is a reflection, and it is a reflection with the x-axis. So negative x plus 3, let's try to use another color, and I'm going to use the red one. Negative x plus 3 is going to be right here. That is going to be negative x plus 3 square. Now, if I look at the x plus 3 square plus 1, now I have an horizontal vertical shift, and this vertical shift has to be plus 1. So I'm going to be at plus 3 right here, and I'm going to use the green one, and I'm having is plus 1, which will be right here. And I'm supposed to have something looking like this. And that is going to be negative x plus 3 square plus 1. What is the domain and the range of this function? Well, the domain is going to be minus infinity plus infinity. Okay? The domain is going to be minus infinity plus infinity. The domain is read on the x-axis. But the range is going to be negative infinity plus 1. Knowing now the expression of the vertex formula, I will let you do the example number 3 to find the vertex. Pretty easy when you have A equal 2, B equal 4, and C equals 6. Okay, so pay attention, especially when you are going to calculate f of minus b over 2a. Usually this one I don't have any problem with students. Most of the time students are going to make a mistake when they are going to calculate f of minus b over 2a. So pay attention to that, and we will talk about that in class if it's necessary. I will let you do also the example number 4, which is a word problem. Remember what the advice I gave you already regarding the way to solve, how to solve a word problem. First advice, read properly by reading slowly and putting emphasis in words. And second of all, try to represent the problem in another way. And usually we draw a picture of the problem. All right? I will talk to you in class and to see if you were able to solve the problem or not.